Good evening, everyone. Like we are trying to discuss about the in the morning session. So what we are trying to discuss something like a iterator. So how this particular iterator is working internally, we need to understand very carefully. So observe carefully. We identify the this particular two array as well as one more two array. It is trying to take as a additional parameter so that we are passing here. Okay, it's like a array reference we are passing and the same whatever the type we are going to pass, the same type it will try to return here. And finally, we are moving into the one of the important method called iterator. So what we are doing basically now, we'll try to discuss about the this particular iterator, how it is going to work internally. We'll identify where this particular iterator is opened internally. Let me close these are all the classes. Okay, so we are trying to discuss about the one of the important class called iterator, like sorry, one of the important method called iterator, and how this particular iterator is implemented. If we observe, whenever I'm trying to open this particular iterator method, so inside this particular hash set, this is the iterator method is created, and internally we are trying to call this particular map dot keyset dot iterator. Okay, so map dot keyset dot iterator. Now, what we are doing is we already identified here internally how this particular code is implemented. So this is the one of the keyset we have a one class. Get in the pen. Once this particular class is completed, we are calling on the so inside this particular class here. Okay, so inside this particular class, we need to understand how this particular iterator is implemented. So what we need to understand here, we need to understand the first we need to understand this particular key, the key set, how it is implemented internally. So let's observe here. This is the key set implementation. Okay, inside this particular hash map as well as this particular linked hash map it is implemented. Now you can see, so key set, this is the key set method we are calling, and internally it is trying to return this particular key set. If this particular case is null, we are trying to create this particular key set. So here you can see we implemented the key set. Okay, so this is one of the final class we are having, and we are trying to extending this particular abstract set here. Getting the point. Internally, we are trying to extend this particular abstract set here, and we are trying to have some methods here, and how these particular methods are implemented internally. Now you can see size method, clear method, and iterator. So what we are doing is we are trying to call the one of the constructor call so key iterator. This is important because we are trying to discuss about the iterator method. And this particular iterator method internally, it will try to call this particular new key iterator. Okay, so whenever I'm trying to expand this particular key iterator, because this is the one class they define here. So key iterator is the one class, and it is trying to extending from this particular has iterator, and internally we are overriding only one of the important method called next method. So internally, it is trying to call this particular next node dot key. Okay, this is important. Now, what I will do whenever we are trying to call this particular iterator method, we'll debug this particular code how it is trying to implement internally. Okay, now observe carefully. So how we can identify this particular methods are going to call internally, and add method we already identified, add all method we identified. Now I'm trying to discuss about the iterator. So now you can see we are calling on map.keyset.iterator. If we observe map.keyset, so we are inside the hash map. Here now you can see we are inside the hash map because how we are calling map.keyset method we call here. Okay, this method we call now map.keyset. So map is a reference variable of this particular hash map because internally we created object of this particular hash map with help of this particular key and value. Okay, So this is the one of the object we created here. Getting the point. And finally, so based on this particular references, we are calling key set method. So this is the key set method is calling inside this particular hash map. Now observe carefully what I am doing here. I'm trying to set this key sets here. So right now we need to identify what is the key set. So case is null. Okay. Here also you can see inside this particular right side variable section, the key set is null. So once a key set is null, I'm trying to create a new key set object here. Okay. And so I'm trying to set as a key set whatever the instance variable we defined here. I'm trying to set as a this particular instance variable. So finally I'm setting this particular key set. I'm trying to return this particular key set. Now what I'm doing is, once the key set object is created, I'm trying to call on the iterator method. Now you can see, so where we are moving, we are trying to move on the one of the important class called key set class, and this is the finally class. Final class this is. Okay. So this is important, we need to understand. Once this particular final class we created and we are trying to extending from the abstract set here. Abstract set. And what we are passing here? Key we are. Okay, here we are trying to pass this particular. Okay, here the abstract set internally it is trying to extending this particular key value. Okay, now once it is completed, which method we are calling? Iterator method we are calling. So whenever we are calling this particular iterator, now, so which constructor we are calling? So the constructor we are calling here, so key iterator. Now if I am going to call this particular key iterator, observe carefully, we are calling on this particular key iterator class, and we'll try to extend like executing the new key iterator constructor. Okay, so this is the constructor. Getting the pen. So this is the key iterator constructor is going to call. So now what I am doing is I'm trying to providing this particular return type. So what is the return type we are having? Iterator string. Why I'm getting this particular string? Here the hash set we provided as this particular string. Okay, hash set we provided as a string. So once we provided this, now what I'm doing is iterator dot whenever I'm trying to call this particular next year, how many values we are going to print? Only one value. Only one value we are going to print. So this is important, we need to understand here. Okay, I will try to restart this. Now we'll understand here how this particular example is executing here. Okay, so once we call this particular iterator, now we are getting the iterator object and I'm trying to call the next. Now you can see only 12 we are getting. Okay, only 12 we are getting. So where exactly this next method will call here? This is the declaration about this particular next method. So inside this particular iterator, we are having this is the declaration. Now I will open this implementation. I will open this particular implementation. Now you can see. So these many classes, the iterator interface is implemented. So what is the information we need to understand? So key iterator. Okay, so this is the key iterator we are having, and we need to discuss about this particular next year. And I want to put a breakpoint if this particular 1492. Whenever we are calling this particular next method, it will call wherever I put a breakpoint here. Okay, now you can see this is the next method is calling, and this is the different one. And here I'm calling the println, and from here what we are calling here, value of method, toString method we are calling, and here we are calling the it.next here. It.next. So whenever we are calling this particular it.next here, because internally we are calling the iterator method, and this iterator method internally it will try to look up the key iterator, and new node method will call internally. So now you can see it is calling this is calling key iterator, and we are calling this particular new node dot next here. Okay, so this is we need to understand here how this particular new node method calling, from where we are calling it. So this is important. Basically we are calling println. Where we define this particular println, here we are defining. Okay, the line number 24 we are calling the println method, and this is the println method is calling internally, and we are calling the value of, and this value of internal it is calling on the iterator, like a toString method is calling. Getting the point? It is calling this particular toString method, and internally we are having iterator, we are loading the iterator, and this is the it dot next method we are calling. Finally, we are at this particular next node. So what you need to understand here, mod count. What is the mod count right now? Here you can see expected mod count is 6 here, and where is another mod count here? Okay. So I'm not getting this particular mod count. Let me inspect this. Yeah. So now you can see mod count I'm getting as a 6, and expected mod count also we are getting as a 6 here. So whenever basically these values are same, but what we are doing is we are trying to, when this particular values are not matched here, we are going to get an exception, concurrent to modification exception. Okay. But right now we will not get any exception because both values are same. And what is the condition we are using? Not condition. Whenever both values are not matched, then only we'll get in this particular error. And now you can see E. What is the E right now? So next we are calling it. Okay, here we need to understand E. So this is the next value we are getting, so 12. Okay, so this is not a null here. This is not a null. Now finally, we are trying to check this particular condition. Finally, we are trying to check this particular condition. If the condition will satisfy, we have a do while statement here. So now you can see do while. Inside the do, I'm not writing anything, but the while I'm trying to write the code. Okay. Here we are trying to repeat the do while iteration loops here. Okay. So what is here we are doing something like initialization, and once all the initializations are completed, we are checking the condition. So we'll see what happens internally. It is not matching here. Okay. So this particular condition is not matched here. Directly we are trying to returning this. Directly we are trying to returning this. So once this particular e value we return, what we are doing here, we are going back to the it dot next here. Okay. What is the e value? So we are getting 12. Okay, we are getting 12. So once we get this particular 12, now what I am doing here, if E equals to this, we'll try to add as a this collection. Otherwise, we'll try to add as a this E. Now you can see. So append here how it is implemented. We open one array bracket here, and 12 we appended. Now we are going to close here. Okay. But right now, so one more append we are calling. So this is the infinity loop we are calling. So one more time we are calling the next method. Now you can see. Now what is the next value? Now, what is the next value? 45. Getting the point. Right now, we are getting the 45. Again, we'll check this particular conditions here. First condition will not satisfy. Second one also will not satisfy. And one more if we are checking here. So this also, it is not satisfied here. But how this particular next is coming? This is important. How this next is coming? Here, inside this particular has iterator, we are providing this particular next here. Okay. Every time it is trying to returning this particular next, and here we are going to call this particular has next, and if this particular next is not null, it will return the true. Otherwise, if the next is null, it will return false here. Okay, so this is important. Finally, we are trying to returning this particular e, and something like a 45 value we are going to return. Okay, now you can see we are returning this particular 45 value, and here what we are doing is we are trying to returning only key. new node dot key we are calling. Okay, so it will return the key value, not the value of value. So only it will return the key. So this is we are appending this particular key. If you see this SB, so 12 comma space and 45. So one more time it is repeating, and again we are calling the next method. Now you can see this is the third time we are calling, and now what you understand here. So why this particular condition is satisfied here, we need to understand 78 here. Okay, so 78 here. Now what, how this particular condition is matched here. So this is the E we are trying to setting into this particular current, and later we are calling if the next is null. Getting the pen? If the next is null, and whatever the table we are having, I am trying to set into this particular T. It again one more condition we are making not equals to null. So here we are having two conditions. So this is the one condition, and this is the another condition we need to understand here. Whenever we are having this particular condition, I am trying to load this particular next here. Okay, I am trying to load this particular next. We need to understand. And now you can see, so we this particular value we repeated only one time, and finally we are trying to returning the same, the key call 88 78. Okay, so this is the one more iteration of this particular toosing, and this is the way of calling internally. It will try to call multiple times. This it dot next method it is calling multiple times. So finally whenever this particular it dot has next will return the false, then it will try to append this. Okay, this is important, we need to understand here. Now I am going to release this, and I will print this. Now you can see finally. So this is the next method we are calling from our code here. Getting the pen? So this line number 23 we are calling only one time the next method. Because of that it is returning the 12, and the line number 24 internally it is calling the toString method. So these are all the outputs is printing. Okay, so this is the way of the execution of this particular iterator. This is very important here. So in the hash map we'll discuss more about this particular iterator later, and the hash map will contain the different iterators. But right now, hash set will contain only one iterator here. Okay, this is important, we need to understand here. This is important, we need to understand very carefully. And what is the another important method we need to discuss here? Because to array add method we discuss here, add or also we discuss here, and remove method. So remove method, how it is going to remove the object here. I'm trying to comment out this iterators here, and here remove method, and here I want to pass object here. So what is an object I am trying to pass? 1 2 3. Okay, and we'll see how this particular remove method will remove the object from this particular hash map here. And I'm trying to click on this particular remove method now. So we'll see what happening internally, map dot remove, and we are trying to check this. And what we are checking here, so this remove method internally it will return the value. It will return the value. So the value we are checking here, if the value and it is matched with this particular present, it will return true. Otherwise it will return false. Okay, otherwise it will return false here. So we'll identify how this particular map dot remove method is implemented. Okay, we'll identify how this particular map dot remove method is implemented internally. Now I'm calling map dot remove method. So now you can see what is the key we are passing, something like 1 2 3. Now observe carefully here. Here we are trying to call the hash. Okay, here we are trying to call this particular hash code. So first we'll load the hash code of this particular 1 2 3, and once we load, we'll call this particular remove node here. Okay, we are going to call this particular remove node. Now observe here how we are going to call this particular hash code. So this is the key dot hash code method will call, and to generate the hash code of this particular key. So we identified the hash code. Now I'm calling this particular remove node. Now what is the hash code? 48 to 690. Okay, 48 to 690 we are having the hash code. Now if you see, to identify the appropriate node, what we are doing here? First we are checking the table. So this is the table right now we are having. Now you can see 1, 2, 8 and 13. Okay, 1, 2, 8 and 13 we are having. These are all the nodes like indexes here. And finally inside this particular first, it will contain internally two more nodes, because we are having some next node relation here. Next node relation we are having. Okay, so what I'm doing here, I'm trying to setting into this particular tab. After this I'm checking the condition not equals to null, and here I'm trying to find out the length into this particular n, and finally we are checking this particular greater than 0. Okay, and we are having the AND operator, and we need to identify these are all the code. So we'll see how this particular if condition will satisfy or not. So if condition is satisfied here, whatever this particular code we written here, this is the condition. But before checking the condition internally, it is trying to initializing the value. After that, it is trying to check this particular condition. Okay, now observe carefully. And here we need to understand here. So node we are defining. Okay, so this is the node type, and after this we are trying to defining one more e, and this is also same for this particular node type. So key and value we are defining. Getting the point? So these are all the declarations here. We are not initializing it, just we are declaring this. We'll see where we are trying to initializing this. Now you can see we are checking the hash code. Okay, here we are checking the hash code here. This is important. So this hash code, it should match it with this particular hash, and the key is equals to this particular key, and it should match this particular key here. Okay, otherwise it will move on to this particular section. So any one of the condition is satisfied. So it is satisfied. Whatever the P we are having, now I'm trying to initializing into node here. Now you can see what is the node is identified. So this is the 1, 2, 3 node. But how it is identified here? This is important here. So this is the condition we need to check here. Whatever this particular condition where I am trying to highlighting here, this is important. This particular condition only, it will try to identify the node here. What we are checking here? Hash code as well as the key. Okay. Finally, we identify the node. Now we come back to here, and again I'm trying to check this particular section value. So value I'm checking because key identified. Now we are trying to check with the value. So we'll see how this value is matching here. So this particular condition is satisfied because each and every key will contain the same value. Getting the point? Only the same value we are trying to store for the multiple records here. And observe here, we are checking this particular tree node. This is not the tree node here. And we are checking here if node equals to P. If this particular node equals to P, now what we are doing here? We are trying to find out here. We are trying to find out this. So here I'm trying to providing this particular index here. The index is 2. And here, whatever the node dot next, whatever this particular node dot next we are having, I'm trying to set. But right now we are having null. So what is the node we are having basically? It is like 1, 2, 3. The 1, 2, 3 node, it does not have any next node references here. Okay. So anyway, if it does not have here, we are trying to store in the second index location as a null here. So right now we are having 1, 2, 3. This 1, 2, 3 is replaced with the null. Okay. This 1, 2, 3. Now it is replaced with this particular null here. So observe carefully. After this, now you can see the second record is replaced with a null here. But finally, what we need to understand here, this is very important here. Getting the point. So this is very important here. Now, what I'm doing is whenever I'm trying to providing this particular remove method, first it is identifying the appropriate node. Getting the point. It is trying to identify this particular appropriate node here. Getting the point. And once it is identified, it is trying to checking with if the current node is having any next node, it is replacing with the next node. If the next node is does not have any information, we are going to store as a null. Okay. So once we are storing as a null, the node is no longer usable. Getting the point. Now the size also we are trying to decreasing it. So once we are decreasing it, we are trying to print this here. Okay. So we are checking the remove method. Finally, we are printing this. So what is the value we are removing? 1, 2, 3. So this particular 1, 2, 3 is removed here. So now you can see there is no 1, 2, 3 information inside this particular hash set object here. Okay. So any questions here? Anyone having any questions? So regarding this iterator as well as remove method. This is very important section because hash set internally, it is working on the hash map, and whenever we are trying to working on the hash map, loading, insertion and deletion, it will try to look up the hash code as well as the keys here. Once the key is identified, it will try to find out the appropriate node and it will update or delete or as well. Otherwise, it will try to load the node information. Okay, so this is important. We need to understand for this particular hash set. But what we can understand, so whatever the duplicate element we are going to store, the duplicate elements basically it will not going to store inside the hash set here because of this particular hash code as well as key. Okay, because of this particular hash code and key, the duplicate elements we cannot insert into inside this particular hash set here. Okay, we identified the remove method. Now if I'm going to call this particular remove all, how it is going to work. So observe carefully. Here only I'm going to call the remove all method. Now instead of passing this particular 1, 2, 3, I will pass AL. Okay, I'm going to pass this particular AL. So we'll identify how this particular remove all method will work. Just now we identified the remove method. Now we are moving into the remove all method. So now you can see I'm trying to debug the same code, remove all method. So we are moving into the abstract set here, and internally just we are checking one condition, and the condition will satisfied. Now I'm calling size greater than c dot size. Okay, size greater than this particular c dot size. Now what I'm doing is I'm trying to call this particular for each loop. Okay, here I'm calling this particular for each loop, and finally we are calling the same remove method. Okay, you can see here we are calling the same remove method here. Getting the point? But this remove method will call from the loop here. Getting the point? How many based on the elements here? Getting the point? Based on this particular element, we are going to call this particular remove method here. This is important method we need to understand here. Okay, only one difference is here. For this particular remove all, we are creating one loop here. Inside this particular loop, we are calling on the same method. Okay, whatever the remove method we discuss here, the same method is going to call internally. Okay, this is will remove the all the values here, and only 1, 2, 3, comma 789 we are having. 1, 2, 3, 789 we are having here. Okay, this is important. So why we are having only 2? Because it is matching with these 3 records here. Because these 3 records only we passed here, the AL here. Now finally, this particular AL is going to, whatever the object we are having, all the objects are going to remove here. Okay, this is another important information we need to understand. And finally, retain all method. So we discuss about this particular retain all in the two classes, linked list and array list. Basically what it will do, whatever the array list, like whatever this particular collection we are going to pass, if any record is matched here, the matched records will available and unmatched records are going to remove. Okay, unmatched records are going to remove. So in our case, these two records, so 1 2 3 7 8 9 will not print, and remaining, so 12 45 78 and 96, these records are going to print here. Now you can see, now you can see, so 12 45 78 96, so it is available, but only 1 2 3 and 7 8 9, these two records are unmatched with this particular AL. So whenever the unmatched records are going to remove here, only the matched records are will available inside this particular hash set. So this is only the retain method will work internally. Getting the point? So this is also very important here. Matched record is not going to do any changes. So whatever the unmatched records we are going to have, it will call internally the same remove method and will delete the object from this particular hash set. Now if you see here, what I am doing here you can see contains method we are calling. Okay, contains method. If this particular contains method will not return true, at the time of returning true, it will call this. Otherwise, it will not call this particular method. Okay, here what we are calling it dot remove method. So the same remove method internally, it will try to look up the node, hash code, key value, something. Based on that, it will identify and it will remove the. Okay, so this is important. And now we identify this particular retain all. Now we'll move on to the contain method. So what exactly the contain method will work here? So basically, whatever this particular object I'm going to pass, whatever this particular object I'm going to pass, this object is available or not, it will try to identify. Okay, this object is available or not inside this particular hash set, it will check here. If it is available, it will return true, otherwise it will return false. So for example, I'm going to print this. Okay, now if I'm going to print this, it is returning true. Okay, here you can see, here it is trying to return true. So how it is implementing internally? Now we'll identify this. Now you can see map dot contains key. Okay, internally we are calling hash map, one of the method called contains key. Now if I'm going to provide this, now here we are calling the get node here. Again, now you can see what we are printing, like we are trying to generate the hash code. Again, we are calling this particular hash code method. Internally, we'll generate this particular hash code and we are passing this particular key. Now you can see, so hash code and key we are passing. Now finally, what we will do, here again, whatever the table we are having, we are trying to initializing into this particular tab. Again, we are checking the not equals to null and we are checking this particular length. And here we are trying to check about the hash code and all those things. If the hash code, this particular condition is satisfied, now first dot hash code and we are matching with this particular hash code. Same way we are trying to check in with this particular key. If it is matched here, we are trying to returning first. Okay, we are trying to returning the first node. Otherwise, again we are checking this first dot next. If the first dot next is not equals to null, we are checking internally tree node. Otherwise, we are trying to check this particular do while loop. So each time what we are doing is we are trying to check the e dot next here. Okay, e dot next here. This is important here. Getting the point? This is one of the important information we need to understand here. This is all about the particular contains key. Contains key internally important here. First we are checking the hash code. Later we are checking the key. If the key is matched, we are returning first. Otherwise, we'll move on to the first dot next. Getting the point? Otherwise, we are moving into this particular first dot next, and this is the way of checking this. Otherwise, simply we'll return null. Whenever we are trying to returning null, now what we need to understand, if it is returns null, if it is returns null, so this will return the false. This will return the false. Whenever we are trying to returning some value, if it is not equals to null, then only it will return this particular true value. In other cases, it will return false. So because here we are trying to return the boolean value. Okay. So this is all about the one of the important example we are discussing, contains method. So it's like checking the value. First we will generate this hash code of this particular key, and with help of this particular hash code as well as the key, we are trying to identifying the node first. First, we'll identify the node. If the node is identified, we'll return true. If the node is not identified, we'll return false. Okay. So this is the contains method internally implementing like this. Okay. So one more question, like whether we can insert the null values or not. Getting the point? If I'm going to insert null values, what happens here? Okay. So we'll see how this particular the code it is going to import here. Now hs dot add I'm calling, and here I'm trying to pass null. Okay, here I'm trying to pass null. So we'll see how this particular, whenever I'm trying to inserting this particular null, how this particular add method will work internally. Now you can see, so constructors like add method I'm calling. So this is the add method we need to check. Okay, here I'm trying to pass null values. We'll see what happens internally. Okay, we are calling put method. We are calling this particular put method, and again I'm calling the same put method. So hash code method we are going to call, and what is the hash code value for this particular key? What is the key we generated as a null? Okay, we'll see what is the hash code. Hash code is 0 because the key we are trying to inserting as a null. Getting the point? We are trying to inserting as a null, and what about this particular value? Object array. Okay, we are not going to check anything. So table, it is not a null, or this section also I hope it is not equals to null. So if condition will fail, now we are checking here the tab here. Now you can see it is satisfied. So what is the I value we are getting? 0. What is the I value we are getting? 0. Now what do you understand here? We can insert this particular null records, but only one record we can insert here. Getting the pen. Only one record we can insert. And another important information, so this particular null records are going to store in the first index location. In the first index location. Something like in the first node. Because so right now we are having 16 is the default capacity, and so it is starting internally 0 1 2 something like 16, and based on the hash code we are trying to identify the index location. So we have a different index locations here. Now if you see here, I can see this particular tab. Here we can see first record is inserted in the second index location. Another one is inserted in the 8 index location. So something like only two records are we are having right now. Only two records are we are having right now. Okay, this is important. We need to understand. But whenever I'm trying to inserting this particular null value, so in the which index location it's going to store? In the first index location, that is called 0. Okay, in the 0 index location it will insert. Now you can see here in the 0 index location is it is inserted the key as a null and the value as a object here. Okay, but what you understand here, only one time the null record we can insert only one time. If you are trying to inserting the same null record, it will replace here. Getting the point? It will replace this information here. Okay, so this is another important information we need to understand. The contains method also we identified, and now you can see, so null is trying to get as a first record. Is trying to get as a first record, and after this we are trying to print the remaining values. Okay, so is it clear? Now, so same way we can discuss about the contains all method. Same way we can discuss about the contains all method, how it is working internally, and we are close to this particular hash set here. Only the what is a one method is pending, clear method. Clear method, what it will do internally, it will try to remove the object from the hash set. So hash set internally, it will try to look up the hash map here. Now I'm trying to comment out this, the contains method, and here I'm going to call hs dot clear method I'm calling. Okay, whenever I'm trying to call this particular clear method, first we'll identify how this particular clear is implemented. Now you can see we are calling the hash set dot clear, but internally it is calling map dot clear. Map dot clear is nothing but hash map dot clear. Now what you need to understand here, based on this particular condition, we are repeating this particular loop, and for each and every iteration we are trying to make as a null. Now you can see the tab of I. Okay, tab of I, because what is the tab? Tab is equals to node array. Okay, it is equals to node array. Inside this particular node array, for each and every index location, we are trying to initialize as a null value. Something like all the references will not have any values. We are making as a null here. So this is the internal implementation of the the particular clear method. Now what it will do, whenever we are calling this particular clear, we don't have any records here. It is empty. Okay, it is returning empty. Getting the point? This is important here. Okay, so we discuss about the one of the important the implementation class called hasset here. Hasset is the one of the implementation class of this particular set interface. Okay, this is the one of the important information we need to understand here. So any questions here regarding this particular hasset? Anyone having any questions here? Okay, if we don't have anything, now we are going to discuss about the another important class, something like a linked hasset. So first we identified here array list and linked list. These are all the list related implementation. Now we are discussing about the hasset, and one more class I'm trying to create here, something like linked hasset. Okay, I'm trying to providing linked hasset here. So this is the another important class we need to understand. This particular class also is implementing from the set interface. Okay, is implementing from this particular set interface. Now you can see linked hash set. Okay, what is the E we can provide? So you can provide any data type here. Getting the point? We can provide any data type here. So I'm going to provide all the data types with this particular string. Now you can try with another data types, whatever we are having, something like integer, double float, character, and a boolean data type you can try. Okay, so this is the one I'm trying to create, linked hash set, LHS. Okay, and linked hash set. Now you can see how many constructors we are having here. So first one is the default constructor, second one is expecting collection as a constructor, and the third one is expecting initial capacity, and fourth one we are expecting flow to the load factor also. So something like the same constructor whatever we are having hash set, whatever we are having the hash set related constructor, same constructor we are having inside this particular linked hash set. Okay, linked hash set. Now we'll discuss about this particular constructor, how it is working internally. Let me remove this particular classes. The unwanted classes I'm trying to removing it. Now observe carefully. I'm trying to open this particular linked asset. This is the one of the important class. Now what we are doing here, we are trying to call the super. Okay. What we are doing here, we are trying to call this particular super. So super, the key, when we are calling this particular super keyword, what we need to understand, what is this particular class is extending. So linked asset internally, it is extending from this particular asset. Now what is the use of this particular class here? Now you need to read this, some code here. So some information we can read this so that we can easily understand here. So here they are trying to providing this particular hash table. We'll discuss later this particular hash table information. Now we'll identify what exactly it is going to provide. What exactly it is going to provide. So it is going to provide the ordering. Okay. It is going to provide the ordering. But whatever we created inside this particular asset will not get the order basically. Okay. We will not get this particular order basically. Now if I'm going to run this example, will not get this particular order. Okay, this null is getting as a first index here and remaining this particular 12, 45, 78, 96 we are getting, and later getting the point. So 1, 2, 3 we are getting. Now you can see 96 we are getting as a lost record. 96 we are getting as a lost record. So we are not getting the order here. So whatever the order we are inserting here, we are not getting the same order inside this particular asset. Why we are not getting it? Because internally it is trying to work on the hash code mechanism. Okay, it is trying to work on the hash code mechanism. Now we need to understand this particular linked hash set here. So this particular class is internally it is extending it, and so internally it is trying to link the node information. So whatever we discuss inside the linked list, the same concept is going to implement inside this particular linked hash set here. Okay, so because of that, it is going to have the same order whatever we are going to insert here. Whatever the way we are going to insert here, the same way we are going to get the data. Okay, because here now you can see it is going to provide the ordering here based on this particular asset. Okay, we'll see how it is going to internally it is going to provide. Getting the point? We need to identify the how this particular linked asset is going to provide internally. Now observe here, we are creating an object here and LHS dot. Again, I'm going to call the add method because we don't have any specific method. Whatever the method we are coming from the collection interface, the same method we are going to use. So if you want to understand, now you can see it is extending from the hash set and it is trying to implementing from the set interface. There is no another interface here. Only one interface we are having here, something like a set interface here. Okay, so set interface internally is implementing from the is extending from the collection interface because these two are the interfaces. Internally, they are going to use the extends keyword. This is important here. Now we'll call this particular add method, and here I'm going to providing something like hash LHS dot. Again, I'm going to call the add method, something like a set method I'm calling, and LHS dot same add method I'm calling here, and here I'm going to provide linked. Okay, so something like a linked hash set here. So finally, if I'm going to print this LHS, now you can see we are getting the linked hash set. Getting the pen? We are getting this particular linked hash set here. This is important here. How we are inserting? Same way we are getting here. Now you can see here we are getting the same way. So if I'm going to inserting like before this particular linker, if I'm going to call add method something like 789, Now you can see 789 is the first record. Now if I'm going to insert this LH dot add method, and if I'm going to provide 963 as a ending record, and between this particular hash, if I'm going to add one more record, okay, something like so 852, okay. Now we'll print this. Now you can see 789 linked hash 852 set 963. So whatever the way we are inserting, the same way only we are getting the value. Okay, the same way only we are getting the value. Now we'll debug this particular code so that we'll understand here how this particular add method is implemented inside this particular linked hash set. Okay, now I'm moving here. Now you can see here I'm calling this particular map.put here. Map.put. So why it is calling the map.put here? Because the linked hash set internally, it is calling this particular hash set here. Okay, it is calling this particular hash set. So what is the hash map here? Now if we observe carefully, it is calling this particular linked hash map. Getting the point? Earlier, it is printed as a hash map here, but right now it is printing as a linked hash map. You can see here linked hash map. So which object we are calling internally? We are calling on the linked hash map. So I'm going to move on this put method. Again, we are calling the hash code. So we'll identify the hash code, and again we are calling this particular put value. Okay. So this particular the same code we are calling it. Now you can see. So tab. What is the tab we are having? 8. Okay, in the 8th index location, 789 we are going to store. Okay, in the 8th index location. So what is the hash code of this? Something like a 54648. But what we are doing internally, we are trying to work on the linked hash map. So whatever we are having here, it is going to work on this particular linked hash map. So because of that, we are getting the same order. So how we are inserting it? Same way we are going to get this particular example. Now I will show you the particular class here, linked hash map. Okay, it is extending hash map and it is implementing map interface. Now we will see the same add method. So add method is no longer available. Getting the point. But what we need to understand here, now you can see this is calling linked hash map dot entry. So this is the head related and this is the tail related. Now we'll identify. So this is the private method we are having. This is also private method. New node. So this is important. How it is creating a linked hash map dot entry, and we are trying to pass this particular values here. So each and every section, hash map, linked hash map, linked hash set. Okay, these are all internally. It is going to use the node concept here. Okay, we'll debug this particular example in the tomorrow session because it will take more time to understand this particular linked hash map, how it is implemented internally. Okay, one of the add method we identified. What is the advantage we are going to get whenever we are trying to work with this particular linked hash set here? Linked hash set internally, it is going to use the linked hash map. Getting the point? And the linked hash map internally, it will provide the whatever the way of the object we are creating. The same way we can load an object here. Okay, and internally it will contain like this. First record, hash code, key, value, and next node. Okay, and second record here, same thing we are going to create like this. So hash code, key, and value, next record. So first one we are going to store as a 789, and here I'm going to provide linked. Okay, so this is going to match with this particular another node here. This is the value and next to node reference. Next references. So and this is the hash. Okay, so same thing. And if I'm going to create a one more object here, it will connect this node to this particular node. And if I'm going to create another one, it will connect to this. Okay, so here we are having keychain here. How we discuss about the linked list, same way it is going to work on this particular linked hash set. Getting the point? Because of this particular manner, we are getting the order here. Whatever the order we inserted, same order we are getting this particular values here. Okay, this is all about the one of the important example we need to understand, the linked hash set. We'll continue the linked hash set tomorrow. We'll discuss about the remaining method, because here all the methods, whatever method we discuss inside the hash set, all the methods are applicable inside this particular linked hash set. And whenever we are trying to debug the code, it will try to call the hash map. Okay, because linked hash map internally, it is extending from this particular hash map only. So these are all the basic information we need to understand regarding this particular linked hash set. Anyone having any questions so regarding our the hash map as well as, sorry, hash set as well as linked hash set? Okay, if we don't have anything, so I'm going to stop the session up to here. So tomorrow morning we'll continue the same linked hash set here. And once we are familiar with this particular linked hash set, and we'll move on to the tree set. So we'll see how this particular two implementation classes are going to work internally. Okay, so we'll continue tomorrow.